Hi students, good evening. So as we have discussed in the last two videos on remainders, I taught you about the fundamental questions and we talked about Fermat's theorem. So in today's session, I'll talk about another important fundamental, Euler's theorem. So the question arises, where do I need to use this complicated name, Euler's theorem? For example, if I have a question which says 101 to the power 400 divided by 1000, I need to find out the remainder. Now the two concepts which we have already learned, the first one, I'll try to divide this number by 1000. Now this is already smaller than 1000, so I can't divide it. Second approach, which says that 101, any power of 101 which is closer to 1000. I don't think it is feasible in the exam to calculate the cubes, the fourth or the fifth powers. Yes, already you know the 101 square, I know, everyone knows. You can calculate it by Vedic math that it is 1 more than 100, so it ends with 01, right? So that means you can calculate it, but is it that easy to answer such questions? You may have number of questions which says 37 to the power 40 divided by 100. Yeah, so many such questions. So is it that easy to answer such questions? Can we have a standard approach to answer such questions? So there comes an answer, yes. So Mr. Euler has given you an answer to such questions. Now to understand the trick of answering such questions, so we need to understand what does Euler's number mean, right? So let's first of all, I'll come back to these two questions, friends. So I'll talk about what is Euler's number. Have you heard of a concept which says this is just a symbol to calculate Euler's number. So if I say number of coprimes to a number less than the number. Number of coprimes to a number less than the number. I hope everyone understands the word coprime. So if I need to find out number of coprimes to 100 which are less than 100, number of such positive integers which are coprime to 100 and less than 100. If I give it a thought, number of numbers which are less than 100, so how many numbers in total? 1, 2, 99 numbers which are coprime to 100, so that means they should not have any common factor. 100 being a even number, any even number does not qualify to be a number which is it has a common factor, so it is not coprime to 100. So all 50 even numbers are ruled out. So how many are left? Rest of the 49. Out of those rest of the 49, do I have numbers which are not coprime to 100? Yes, multiples of 5, so I can deduct the multiples of 5. So I'll be left with the numbers which are coprime to 100. But there is a trick to calculate it. Now understand it very carefully, very important from the exam's perspective. 100 can I factorize as 2 square into 5 square? 4 into 25 you all know, so it can be written as 2 square into 5 square. So the moment I write it as 2 square into 5 square, what is the first prime factor? 2. What is the next prime factor? 5. Euler's number says that I need to write number as it is into 1 minus 1 by A, 1 minus 1 by B, where A and B are the prime factors of that number. So in case of 100, if I need to calculate Euler number of 100, so that means 100 multiplied by 1 in minus 1 by 2. So that gives you 1 by 2, 1 minus 1 by B. So this is B and this is A. 1 minus 1 by B, which gives me 4 by 5. 2 into 5, 10 goes off, so I am left with 40. Now what is this 40 representing? It is phi of 100. So it is Euler number of 100. In other words, it is number of coprimes to 100 which are less than 100. Is that okay? Number of coprimes to 100 which are less than 100. So this is the most important part. So if you understand Euler's number, you can answer two types of questions. One, where it asks you the number of coprimes, to that number which are less than that, and it also answers the remainder questions. Now how come it answers the remainder questions? See carefully. If I write down a to the power phi of n divided by n, the remainder is always 1. Let me explain it thoroughly. N stands for any number. If I have a number a which is obviously co-prime to n, it should be co-prime. Any number raised to Euler number of the denominator when divided by that denominator will always give you a remainder of 1. Right? So in this case, Euler number of 100 was 40. So any number. So that means a, which is a number which is co-prime to 100, raised to power 40 when divided by 100. I need not to bother, I need not to waste time calculating it. The answer will always be 1. Magical, right? So this is one such shortcut which you have to apply in the toughest of the questions to answer such questions. Any number, the only condition is it should be co-prime to the denominator. When it raised to the power 40, Euler number of 100, always divided by 100, the remainder will be 1. Can I extend it? Of course I can. So if Euler number of 100 is 40, can you all tell me what will be the Euler number of 1000? So easy. Euler number of 1000. So the trick says I need not to bother calculating, Euler number conventionally. I can simply say 1000 multiplied by 1 by 2 into 4 by 5, because the powers will change, the prime factors will remain as 2 and 5 only, because 1000 can also be written as 2 cube into 5 cube. The powers are not playing any role in the formula of Euler's number. It says number multiplied by 1 minus the prime factors. And what are the prime factors? This is the first prime factor, this is the next prime factor. So the powers are not playing any role. So 1000 into 1 minus 1 by a, 1 minus 1 by 2, which gives you 1 by 2, 1 minus 1 by 5, which gives you 4 by 5. So this waves off and you are left with 400. So that means Euler number of 1000 is 400. So if I have a question which says 37 to the power of 400 divided by 1000, what is the remainder? Simple, 1. It hardly took me 2 seconds to calculate it and apply it here, right? So can I mug up for my future references? Can I say Euler number of 10 is 4, Euler number of 100 is 40, Euler number of 1000 is 400, and likewise Euler number of 10,000 will be 4000. Any such questions where I have a number raised to the Euler number divided by that given denominator will give me a remainder of 1. I can have a similar question. I'll just give you one of the other example to substantiate this concept. So if I have a question which says 43 to the power of 41 divided by 100, can I answer it? Looks like a little difficult. No, I can still apply Euler's theorem. 100 is a composite number. Euler number of 100 is 40. This power is not 40, but can I reduce it to 40? I can say it as 43 to the power 40 into 43 to the power 1 divided by 100. Using the fundamental which I taught you in the first video, multiplication of remainders is allowed. 43 to the power 40, what is the remainder? Using Euler's theorem, the remainder is 1. 43 is less than 100, so what is the remainder? 43 itself. Using the concept of multiplication, what is the final answer? 43. Done. So I can apply this concept. Last point which can be memorized. What will be the Euler number of a prime number? Looks interesting. So if I have 7, how can I factorize 7? 7 to the power 1 only. If I go to the formula of Euler number, 7 into 1 minus 1 by 7, which gives you 6 by 7. So 7 cancels out, so you are left with 6. So can I say Euler number of a prime number will always be 1 less than that? Let's understand it logically. Euler number of 17. Number of co-primes to 17 which are less than 17. Isn't it funny? Can I simply say all the natural numbers which are less than 17 will always be co-prime to 17? All the numbers from 1 to 16. 17 बेचारा प्राइम है, उसका को प्राइम भी होगा सब कुछ. I cannot have a number which has a common factor with 17. So can I simply say Euler number of 17 will be 16? This gives you a chance to memorize Fermat's theorem as well. Now guys, if you remember, in my second session on remainders, I taught you Fermat's theorem. Fermat's theorem said that a to the power p minus 1 divided by p, the remainder is 1. Can you interlink? Of course, yes. So Fermat is nothing but a generalization of Euler's theorem. If I have a number n to the power Euler number of it, p, what is the Euler number of p? P minus 1. So if I remember Euler's theorem, I can easily calculate Fermat's theorem as well. So that means Euler is the mother of all the concepts in remainders. I need to understand this concept very carefully. That does not end remainders as a whole. We'll talk about one more last Ramban of remainders, but these three videos will help you answer 99% of the questions on remainders. In my next session, I'll take on the last fundamental, that Ramban, which will help you to answer 100% of the remainder questions. Till that time, keep learning, keep practicing questions. Thank you.